Hi YouTube, it's Phil20 again, and what we've got today is basic battery installation. This type of installation is designed directly for people that don't really understand about setting up solar batteries, or if you're trying to set up a 24 volt or 48 volt system. It's pretty important that you actually do it correctly, because if you don't, then you'll cause a big fire and it could be dangerous. So you're going to want to definitely pay attention to how you're doing your system. And the question is, what kind of batteries do you have for your solar system? I'm going to show you two different types of batteries today, and I'm going to show you why I progressively are moving towards the lower voltage batteries and then putting them in series to increase the voltage. I've been running 12 volt batteries for years, and I'm going to progressively remove those and move over to the 6 volt deep cycle batteries. So let's take a look at the first type of batteries. Would be the 12 volt batteries, and the reason why I'm getting rid of them is because they're just not compatible with the system. So let's go take a look. Okay YouTube, this is the 12 volt battery bank that I've had for about 6 years in operation. I have treated them terribly. I've learned several different things about this system that I didn't know before. I knew there was sulfuric battery acid in there, and I thought that it'd be best to just go ahead and put battery acid back in when I was younger, and they tend to work some. They're still functioning today, but when I say functioning, they hold electrical charge up to 12.8 volts, but they go dead really fast. And the reason of that is because the sulfuric acid that was already in there does not evaporate. The water that's in there evaporates. It doesn't actually evaporate. It's called electrolysis. When you put voltage in between plates, you create electrical current, and when you create electrical current inside of water and a electrolyte, it separates the hydrogen and oxygen from the water molecule, and so it separates it and it turns it into hydrogen gas and oxygen. And that's exactly why you want to ventilate your system, because it's explosive. Oxygen and hydrogen is flammable, so it comes to be a perfect situation to cause an explosion. So that's why you want to get rid of your HHO gas in your vented system. Now I want to show you what I've got here, and I'm going to set my voltage meter to direct current. Sorry you can't see because the lighting conditions aren't very good here. So I got it set to direct current. VDC is what it says on my meter, VDC on auto. And I'm going to turn the light on for you so you can see. And we've got 3 batteries wired in parallel. Let's take a look at them. This is the negative, and this is the positive. And it says 14.46 volts. And the reason why it says 14.46 volts is because my solar array is currently charging these batteries. So let's go over here, and it also says 14.46. Now, the reason why these are reading 14.46 is because they're wired in parallel, and they're considered a 12 volt battery. So yeah, they're doing around 12 volts. You're not going to see an exact number of 12 volts, but what you will see is the system running in parallel. It's going to maintain the the volts at the same amount, but the amps increase. Now I'm going to show you a battery bank of 6 volt battery bank where the volts increase and the amps don't increase. They just remain the same. But it doesn't mean that since your amps don't increase, you don't get any more power. That's not exactly true, because you got the voltage increase. So volts times amps equals watts. So if your volts increase, that means your watts will increase as well. So let's go take a look at a battery bank over here that is wired in series. This one is running in parallel. The one we're going to look at is in series. Okay, here is our 6-volt battery bank that is wired in series. There's 4 of them, 6 volts in each battery. And then if you wire it in series, it's going to increase the voltage for each battery by doubling it. Now, for instance, this battery here is a negative on this side and the positive on this side. This says 6.32 volts. And then this one says 6.32 volts. And then this one says 6.32. And then this one says 6.32. Now, so since we have a system that has 4 batteries that have 6.32 volts directly on the terminals of the battery, why would we have 24 volts if we wired them in series? And if you look, I got one connector wired to this one, okay? So that means between this positive and this negative, it's just a jumper in between the battery's internals. So since I'll go from this negative to this positive, I should have 12 volts. 12.63 volts, 12.64, 12.63, 12.64. If you didn't see it, I'll do it again. Okay, so we got that voltage at 12.63, 12.64 currently. And why would we have that? Well, that's because the internals are jumped just like a standard car battery would be, because there's 3 cells in this system and 3 cells in this system. So each cell contains around 2 volts. And when you jumper the internals, it's going to create around 12 volts, depending on how much the battery is charged to. So if we look at 3 batteries, we should have an additional amount of power. So we go on from the positive on this one to the negative on the 3rd battery. Now it's showing 18.95 volts. 18.95 volts is not something commonly used. You might see some of these in forklifts. But for our application, we have a 24 volt inverter, and we need to increase the voltage to 24 volts. Now we're seeing a voltage of 25.2 volts. And 25.2 volts is fairly good amount of charge capacity. I don't think it's completely full. It's 90% charged. These have not been put on a charge bank yet. And once I get the next amount of batteries, which will be 8 to 12 more, I will put them on a charge bank all together. Now I'll charge them completely before we start operating the battery bank itself. We're standing at 90%, which is fine. You know, in each one of these batteries are showing a very equalized amount of charge, as far as I could tell. Now I could actually test the voltage of each individual cell by opening this cap. It's tough to open. There we go. And then I could test the voltage by sticking my terminals directly inside of here. If you do stick your electric meter terminals inside of here and you do not remove the battery acid, it will eat away at your terminals on your connector. Your connectors will rust, and then you'll have to buy new ones. So what you want to do if you did, all you got to do is put some baking soda in some water and submerge it in water. So since we've got a voltage of 6.31, 6.32, we should have an additional voltage when we submerge this into water. So currently we're at 2.022 per cell right now. So that is a good way to start testing your battery terminal. And just to check everything out. But this is how you would want to run it in series. You're going to run a negative to a positive, and then back to the same battery that we came off of the positive, and then go from negative to a positive again, and then you're going to do that again to a negative to a positive. And then once you go from terminal all the way to the other side of the terminal bank, you're going to have 25 volts. You know, it's called 24 volt battery bank. So this is going to be beneficial for me because it increases the voltage, and I don't have to run as thick of wire. The energy loss from the inverter is half of what it is from a 12 volt. Now, people have 48 volt systems, and yes, they work very well. They're much more efficient at creating electricity. The higher the voltage on your inverter, the more efficient your system is going to become. So if you have a 12 volt system and you want to run your 12 volt system, that is not something that's incapable of doing. You can do it, but you're going to lose additional energy in heat when you transfer the energy through your inverter. So you have to step up that power from 12 volts to 120 volts or 240 volts. If it goes all the way to 240, that loses a whole lot more power than it would be at 120, even double the power. So I decided to go with a little bit higher, a 24 volt. That way I can put 3 battery banks in instead of, having one battery bank of 8. So I'll have 3 battery banks of 4, and that's going to put me at 675 amp hours at 24 volts if I do 12 batteries. It's very possible that I might convert into 16 batteries, which will put me up to 900 amp hours. 900 amp hours should be able to run this whole house. I hope it does. What I don't know is if it will. We're going to find that out in this series of videos I'm doing. Right now I'm talking with Alt-E Solar, Alt-E Store, and we're negotiating equipment and preparing everything that I need, so when I get everything I can go ahead and start putting it all together. Once I get it all completely installed and together, that'll be great. I'll be happy, but you're going to be along the way with every step. I'm going to put everything in to this video series for you guys to see. That way you can learn and find out exactly what you need for your application, so you can have what you need when it's time. Not everybody can do it all at once, and I couldn't either. I've had that 24 volt 6,000 watt inverter for 3 years, and it's been a long time, and not everybody can buy everything at once. But when you can buy everything at once, it saves you money in order to do it. You can do a new system. It is recommended to buy all your panels at once, and then buy your charge controller to match your panels at the same time. That way you know exactly what you're getting and everything's done with the panels, because you don't want to mix and match different panels. It's also recommended to buy all your batteries at once. Now I've got 4 batteries here, and I will pick up 8 or 12 more batteries, and when I get those, they'll be installed, and we'll charge all this batteries up at the same time, and we're going to have the same bank. So hopefully, if everything goes well, I'll be able to run my house. I'll be able to run everything in my house besides my electric heater and my air conditioning compressor, or my stove and dryer. I'm not sure how I'm going to go with that. I will put those things in last and convert them over. We'll find out how we charge, because I'm going to try to go with a 3,000 watt system. That way it provides me a sufficient amount of power to provide for my house. I think this is a good topic, but for today this is what's going on, and I wanted to show you what we got here. We've got our battery bank partially wired up. We got 2 more battery banks that's going to be coming in, and we're going to do exactly the same thing as this. And after that, we're going to be talking about the inverter. So this is Philip 20 with Guns, Games, and Racing, and I will holler at y'all later.